Any physics student worth their weight has heard of Newton's laws. He has 3 of them. I and pretty much every other physics teacher that I know go actually out of order in introducing these laws. We talk about the first law and the third law, and then later talk about the second law. And so Newton's first law, oftentimes this is called the Law of Inertia. So what is inertia? Inertia is a property of matter. That's what Bill Nye tells us. It doesn't have a number, but it is proportional to mass. So the more inertia you have, the greater your mass is, or if you were less massive, you have less inertia. Inertia is just the tendency of an object to keep doing what it's doing. Newton's first law comes in a couple of parts. I bet that you know the most prevalent ones, that being an object at rest will stay at rest. The second part is an object in motion will stay in motion. A lot of the times these are the only 2 parts of the law that you hear. The 2 next pieces are what that motion is, and that motion is with a constant velocity, or I'm going to break it down to say at a constant speed in a straight line, just to be specific. Now, unless acted upon by a net external force. This is Newton's first law of motion. So the important pieces in this, again, this idea, constant speed, straight line, that's super important. That's our constant velocity. And this acted upon by a net external force. So what does this external force mean? I like to think of it as, like a human body that I can be pushed on, I can be pulled on, I can push things, so I can have forces external to me, but there are forces inside my body, like my ligaments that are holding my shoulders together, holding my legs on. Those are internal forces inside of me, my body. The external force would be things acting outside of me. Most of the time it's pretty clear what is an external force. Those are things outside of the system. So if this is my box, an external force would be a person pushing on the box. And then gravity would be an external force. Now, that idea of a net external force, where you have force of gravity going down, the normal force, right now, there is not a net external force. There's not a total force. But once you add the force of the push or the applied force, now this has a net external force, and the box is going to slide to the right. This is a super terrible YouTube video, but it has some good animation in here. So I like to think of Newton's first law, or the law of inertia, in relation to cars and the safety procedures, the safety aspects that we've added to cars to make them safer. So when I think about a car, I can see this animation, right? The car is moving, the car stops, and what happens? The car moves, the car stops. Well, that body, the person in the car, is still moving, right? And so the car moves and the person moves, the car stops, then the person goes through the windshield. And we have added seat belts to cars to make them safer. That way, when the car is moving and the car stops, the person stops too, because now they're tied into the car. The next big thing to be added to cars to protect people's safety is actually headrests. And so if you think this car is moving, right? The car is moving. The person is now strapped into the seat. The car is moving. The person is strapped into the seat. When the car stops, the person's head keeps going, which, is fine if you move forward. But let's say you're stopped at a light and somebody rear ends you. If somebody rear ends you, that means the car goes forward, but your head stays in the same spot, and you can get broken necks. And that is why headrests were invented and are now standard in all cars, to protect people's heads from going backwards. Genius, right? I know.